In this video, we're going to take a look at an introduction to Venn diagrams. Now, the main focus behind this video is the notation, and particularly the notation that we need to be familiar with when tackling exam-style questions for Venn diagrams. So let's begin with the first piece of notation here, and let's take a look at what we call the complement. So let's say we're looking at the probability that it rains tomorrow. So if I represent that as a probability of R, and let's say the probability that it rains tomorrow is 0.7, okay? Then the complement of this would be the probability that it doesn't rain tomorrow. And the way we represent that mathematically is almost the same. The only difference here is that we put a little dash above the event here of R. And the way we calculate this probability is to do 1 minus the probability of R. We do 1 minus the probability of R, which in this case would give me 1 minus 0.7, which would be 0.3 there. Okay? And like we said, this is what we call the complement. We'll just jot this down here. So like I said, this is what we call the complement. Now there's two other pieces of notation that you need to be familiar with. The first one here is the intersection. So let's say I've got two events here, A and B. Then the intersection of those two events would be the probability of A intersection B there. Okay, so this little symbol here in the middle, this represents the intersection. So again, we'll just jot this down. Now what this represents here is A and B. So that's A and B. Okay. So if we look at our Venn diagram here, where would that be on the Venn diagram? So where does it represent A and B? Well, that would be this region here in the middle. Okay. So I shade that region, that would be A and B. Okay. So that's the intersection. If we take a look now at the union here, that would be the probability of A union B. This little symbol again here in the middle represents the union. And again, if we just pick a different pen color just to highlight this on our Venn diagram here, this would be A or B. Okay. So where on our Venn diagram would it be A or B? Well, that would be to shade the whole circle here of A. And that includes this region here in the middle, which we've already shaded, but we'll just shade over it. So all of A. And because it's A or B here, that would also include B. Okay, so we need to shade all of B as well there. Okay. And there we go, we get something that looks like that. Okay. The only final thing to mention here is this little symbol that you might see in the top left. And this is just a special symbol. It's actually a Greek letter. And what it represents here is what we call the universal set. Okay, so it looks something like that. And this is what we call the universal set. Okay. So that's a notation that we need to be familiar with. Let's take a look at an example now of actually filling out a Venn diagram. So what we've got here on the screen at the moment is an example of a few different sets. So what I've got here at the top to begin with is what we call the universal set. And we know this is the universal set because we have this Greek letter here. It's very difficult to draw this Greek letter, by the way, but it looks something like that. Again, you can see it here in the top left of our Venn diagram. And the universal set here contains the first positive 10 whole numbers. So 1, 2, 3, all the way up to 10. Okay. And then we've got two different sets here. I've got the set A and I've got the set B. So the set A contains the numbers 1, 3, and 5, and B contains the numbers 2, 4, 5, and 10. And what I want to do here is represent this on our Venn diagram here. So the first thing we do is ignore the universal set for now. Okay, just focus on these two sets here, A and B. And what I'm going to check for here is if there's anything in common between A and B. So what number or numbers is in both the set A and the set B? In that case, it would just be 5. Okay. So 5 is common to both set A and set B, so we put that here in the middle. Okay, that's where they intersect. So we'll tick that off here, and we'll tick that off from the universal set. Now before we take off any numbers here from both of these sets, 2 points to mention about sets here. So we use curly brackets to represent the sets, and the numbers inside the sets here, we call those elements. Okay, so 1, 3, and 5 are the elements of set A, 2, 4, 5, and 10 are the elements of set B. Okay. So for set A here, we've got 1, 3. They're not in B, so I can just put those in A here. So I've got 1 and 3. We'll tick those off from the universal set. And then in B here, I've got 2, 4, and 10. So 2, 4, and 10. Okay. We'll tick those off as well. So 2, 4, and 10. And to finish with here, we're missing 6, 7, 8, and 9. Okay. So the question here is now, where do we place those in our Venn diagram? Well, they don't belong to A. Okay. They don't belong to the set A. They don't belong to B. So we don't put those in the circle here for B. So in that case, what we do is we include them in this square here, or this rectangle. We've got 6, 7, 8, 9, and then we're done. So 6, 7, 8, and 9 there. Okay. And there we have it. So that would be a very basic example there of filling out a Venn diagram. Like I said, just very basic, but just to get that idea across there, and hopefully make you a bit more familiar with the notation that we're going to be using throughout. So that brings us to the end of this video on an introduction to Venn diagrams. In the next video, we're going to take a look at exam revision for Venn diagrams.